To multiply numbers times powers of 10, you simply have to move the decimal point to the right the number of times the exponent tells you. That's the power of 10. So you move the decimal 3 times to the right. Decimal would be back there. We fill in a 0 in the empty spot. So we have 15,090. For number 14, we're dividing by powers of 10. To divide a number by a power of 10, you move the decimal to the left. The number of times in this case, the number of zeros, because the 2 zeros would represent 10 to the power of 2, which represents 2 place value columns. So we move the decimal to the left 2 times. So our answer is 10,381 hundred thousandths. For number 16, we're again dividing by a power of 10. This time it's 10 to the power of 5. Since we're dividing, we're going to move the decimal to the left. Since we're dividing by 10 to the power of 5, we move the decimal 5 times to the left. It means we have to fill in zeros in the empty spots. So our answer is 3,818 millions. For problems like numbers 4 through 7, you have to become familiar with the chart on page 106, or remember the things that I told you in class to associate with each of the different units of measure. We would only be using the ones that are in the chart on page 106. To convert metric units, if you use the table, it kind of provides you with like a roadmap to tell you how to convert from one metric unit to another. If we're converting 7 kilograms to grams, we find kilograms on the table and we find grams. To get from kilograms to grams, we would have to move 1, 2, 3 places to the right. So that means we will have to move the decimal and the number 7 3 places to the right. Since 7 is a whole number, the decimal starts behind it. We move it 3 places to the right. Decimal's now back there, and we fill 3 zeros into the empty spots. So our answer would be 7,000 grams. To convert from liters to milliliters, we go back to our chart, which is again like our roadmap. To get from liters to milliliters, we would have to move to the right 1, 2, 3 times. So we move the decimal to the right 3 times. The decimal's already here, so we move it 3 times to the right. The decimal's now in the back, and we have to fill in zeros in the empty spots. So our answer is a whole number, 500. To get from centimeters to meters, we would start at centimeters, and we have to get to meters. To get from centimeters to meters, we're moving left this time, and we have to move 2 places. The decimal starts behind the whole number. We have to move it 2 places to the left. The decimal's now in front of the 18, and our answer is 18 hundredths. To put a number in scientific notation, we have to move the decimal behind the first digit. The decimal starts behind the whole number. To get it behind the first digit, we would have to move it 1, 2, 3, 4 times. The decimal's now behind the 6. So our answer would be 6 2/10. We'll drop the zeros off the end, times 10 to the power of 4 because we moved the decimal over 4 place value columns. For number 5, again, the decimal starts in the back because it's a whole number, and we have to move it behind the first digit. So we move the decimal 1, 2, 3, 4, 5, 6 times to get it behind the first digit. The decimal's now behind the 7. We have to keep the 15 thousandths, but we can drop the other zeros off the end. It's times 10 to the power of 6 because we moved the decimal 6 places over. To do the opposite, to take a number from scientific notation and put it back into standard form, we're going to do what we did back in the last lesson, in lesson 4. Since we're multiplying times the power of 10, we would move the decimal to the right. We move it 6 times to represent the power of 10. Decimal's now in the back, and we have to add 3 zeros. So our final answer would be 6,793,000. Answer is now a whole number. For 1 4/10, to multiply it times 10 to the power of 4, I would move the decimal to the right 4 times. The decimal's now in the back. Fill in 3 zeros. Our answer would be 14,000. To multiply decimals, you don't worry about the decimal point until you have finished multiplying. 4 times 6 is 24. After you multiply, you have to figure out where the decimal point goes in your product. You do that by counting the number of decimal places in the factors. There are 2 decimal places in the factors, so we have to have 2 decimal places in the product. So our product would be 24 hundredths. For number 4, 5 times 8 is 40. And there are 4 decimal places in the product, so we need 4 decimal places. There are 4 decimal places in our factors, so we need to have 4 decimal places in our product. Since there are 2 empty spots, we simply fill those in with zeros. On a standardized test on a problem like number 4, keep in mind that your answer choice would be 4 thousandths because the 0 would be dropped off the end. But you can't drop the 0 off the end until after you have placed the decimal in the product. For number 29, again, it's regular multiplication. What I mean by that is multiply as if there are no decimals there. Multiply the 1, add your 0, then multiply the 2. Add. Now at this point, you have to go back and count your decimal places. There are 2 decimal places in the factors, so we need 2 decimal places in the product.